Okay, so for limits involving infinity, this is when x approaches infinity or x approaches negative infinity. You can't sub in something that actually doesn't exist. Do you understand that? It's pointless. So actually when you get these questions, it's actually very easy if you understand what to do. So instead, we immediately factor out, the highest power of x in the numerator and the highest power of x in the denominator. And note, these don't not necessarily have to be the same power here. So what we're going to do is we are going to then cancel the x's that we factored out as much as possible, and now we can sub in the limit in the x value for infinity and negative infinity. So what does that mean when x approaches infinity? What does that mean on the graph? I'm sorry? Sorry, say it again. Goes forever. So what would be something that goes on forever? Like if it's infinity, it's far right. And if it's negative infinity, oh, that looks like an 8. Negative infinity, that's your far left. Like really far, right? So when I have something that's approaching something on the far, usually it levels off, right? It's going like this and it levels. That's more like a right hand limit. Let's try this again. A lot of them from last year was like this. Do you see on the far left? It's approaching 0 when x went to negative infinity. And maybe we have a graph that looks like this. And I don't know, let's say it's 2. Right? Something like that. Far right, it's approaching 2. Far left, it's approaching 0. Okay, so we're going to figure out what this is. And what is this called when I have something approaching? What's that? Yeah, that's a horizontal asymptote. So horizontal asymptotes describe a graph approaching a y value as x approaches, what's the far left again? Negative infinity. Or x approaches the far right, which is positive infinity, which I don't usually put a sign. Or it could be both, right? So for a horizontal asymptote to occur at y equals some number, then x has to equal negative infinity. Sorry, x has to approach negative infinity as y approaches the number, or x approaches infinity as y approaches the number, or both. So we're going to do some questions so that you'll figure this out. So the key about this is once we do this factoring out and canceling, how do you sub in infinity now? Because infinity is like, what does that mean? So here's the key. If I have some number other than 0, well, it could be 0, I guess, as long as 0 is not on the bottom. But if I have some number and I'm dividing by either positive infinity or negative infinity, what do we actually get? So think about this for a second. Say the number is 5 on top, and we're dividing by infinity.
Something really small.
So yeah, if you think about this just conceptually, it's some small number and we're dividing by some really, really huge number. So we're going to get a really, really small number. What's the smallest number it could be without changing signs? 0. So that's the key here, is if you take a number and you divide by infinity, it's equal to 0. How about some number times infinity? Yeah, like if you have some huge number, say a billion. So Bill Gates come in here and he's like a 200 billionaire, or I don't know what it, trillionaire, he's a trillionaire. And you give him a dollar. Is that going to add to his wealth at all?
Yes.
He probably won't even take it, right? Because he has so much money. It's kind of like that. If you put something in there and it's so big, it's not going to really affect it. So this is just as big. Okay. So if you put infinity in there, first off, we're going to factor. And once you get the gist of this, you probably won't even show your factoring out, but I'm going to show that for the first couple, okay? So the key here is we're factoring out the highest power of x. So this is the limit as x goes to infinity. And what's the highest power of x for this? X squared. So I'm going to factor out an x squared out of that. And what am I left with? Well, I'm left with 3. Yes? What am I left with for the minus 7x? Yes, minus 7 over x. So you know you're getting it. And then we're getting plus 1 over x squared. Does everybody see that that's what you get when you factor an x squared out? Like if you were to multiply the x squared back in, you'll get what you originally started with, right? Okay, so here's the key. When you sub in there and there and there, what do you get? Well, you get infinity squared times 3. What is 7 over infinity? That's the key. It's 0. So it's minus 0 plus 0. So essentially this is infinity squared times 3. And what is a number that's so small times some absolutely huge number? It's just infinity, right? Like you can't actually square infinity because it's not a number that can be squared, right? It's just an absolutely huge. It's not an actual number, yeah. So we're now going to do it over here. No. You'll see in a second. You'll see in a second. So think about back to grade 12 pre-cal. When we were doing this without actually doing the limits, what we were doing was that horizontal asymptote after we divided. That was the plus k. And that's the thing that shifted it up, right? Okay, so we're going to do it this way. So what's the technique? We're going to factor out the highest power of the numerator. Well, that is a x squared. Then we're left with 5 plus 7 over x plus 1 over x squared divided by, what's the highest power at the bottom here? X cubed. So I'm going to factor out an x cubed. And then we're left with 3 over x cubed minus 10 over x squared minus 1 over x plus 1. So here's the case where we have powers of x on the top and the bottom, so we can actually simplify this part right here. Do you see that? And so what do we get when we simplify that? We get 1 over x. So we get 1 over x, and then this is 5 plus, I'm just going to rewrite it. Like I said, I'm showing way too much work because these are actually pretty simple, pretty simple questions. After a while, you'll just know what to put in. So then this is 3 over x cubed minus 10 over x squared minus 1 over x plus 1. So does everybody see when I sub in negative infinity here, what do I get in this? I get 0. And then if I put infinity in here, I get 0. In here, 0. In here, 0. And here, it's still 1. So it's going to be 0 plus 1 is just 1 on the bottom. Sorry, the 0 is not on the bottom, the 0 is on the top. So 0 times this bracket is going to be 1 on the bottom. And what do I get here? 5 plus 0 plus 0. So I get 5. And 0 times 5 is just 5. No, 0. Okay. Oh, 1 second, 1 second. 1 second here. I don't know what happened to my... Okay, so what's the highest power of x here? X cubed. So I'm going to factor out an x cubed, and I'm left with 2 minus 1 over x squared minus 2 over x cubed. And this is an x cubed there I'm going to take out, and it's going to be 1 over x cubed plus 3. Does everybody see? That's what I get. Now, so to answer your question, is it always 0 and infinity? No. Watch this. Do you see this? Cancels. Does everybody see that? Now when I impose that infinity in, what do I get on top? 2. What do you get on the bottom? 3. So guess what it is? 2/3. So do you remember this from grade 12 pre-cal? A lot of you remembered it this way. If the degree was the same on top and the bottom, it's just the leading coefficients divided. If we go back to the last one, if the bottom was bigger degree than the top, then you knew the horizontal asymptote was at 0. It is the same thing. We're just doing it a different way to get the same answer. But that's why I'm saying, once you know that, it's pretty, like you don't have to show all the steps. So who can tell me the answer here? It is infinity. Very good. Because there's a bigger one on top. What does that mean then, infinity?
It just grows forever.
Yeah, there's no horizontal asymptote. Like when it's going to the left, it's just like it's not leveling out something, right?
There's no infinity place for it to end.
So you have to get it through your head that if you get infinity as your answer, essentially the limit doesn't exist, right? Because infinity is an actual number. So AP will accept both infinity and does not exist as acceptable answers, okay? So again, if I showed my work here, it's an x cubed 4 plus 3 over x squared minus 2 over x squared 3 plus 5 over x plus 1 over x squared. Do you see? This will cancel, but not all completely. You'll still be left with an x. So then you'll get negative infinity times 4 over 3, which means you'll get negative infinity as your answer. So when you go to the far left, it's just going, straight. There is no horizontal asymptote. So if you want to say there is no horizontal asymptote, if they're asking for horizontal asymptote, or you say the limit doesn't exist. So again, here's the key. If you have infinity divided by a number, which that's essentially what we got here, what do we get? Infinity. And what's a number divided by infinity? 0. Does everybody get that key concept there? Again, it's really hard to think of because infinity isn't a really number. And then we're kind of treating it like it has number properties, but then at the same time, it doesn't. Here's some, yeah. Here's something that keeps on cropping up, this absolute value sign. Do you remember what an absolute value looks like? So the absolute value of x looks like a v, right? So when x is positive, it is this diagonal line. When x is negative, it's this diagonal line. Okay? So you got to use this definition all the time. So a lot of the ones, like there was one question on the trig limits worksheet, you have to split it up to 2 limits because you can't, you have to get rid of the absolute value sign. So essentially what this means is when you get rid of this absolute value sign, you got to split it into 2 limits, unless the limit is going from one side, like it has a plus or whatever. So what does this mean? X is greater than or equal to 0. Which limit is it? This is the right-hand limit, right? Does everybody understand that? When it's greater than 0, it's coming from the right. X is less than 0, that's the left-hand limit. Okay. So, let's look at this. X is going to negative infinity. What does that mean? It's going to the far left. So when we talk about absolute values, we wouldn't have to split it up. We know it's this one. Does everybody see that? Okay. So, we're going to do the highest power again. What's that on top? X. So x bracket 5 minus 21 over x. And on the bottom, we are going to take out, I'm going to do this in multiple steps because this is the first time you've seen maybe something like this. I'm going to take out an x squared. So I'm going to still keep it in the square root sign, but I'm going to put an x squared there. And then it's going to be 4 minus 3 over x plus 7 over x squared. Okay, so I'm going to rewrite this now. Okay, did I lose anyone there? All I'm doing is I'm factoring out the x squared, but I'm still keeping it under the square root sign. So now I'm going to actually pull out the x squared from the square root sign, and it's going to become the absolute value of x. But because it's coming, and maybe I'll write it as the absolute value of x, just so I'm not skipping a step. You don't have to show all the steps, but I'm just going to show all my steps for this one for right now. Okay. Did everybody see what I did? I pulled out the x squared out of the square root sign, and it became the absolute value of x. Because this is coming from the, what side? It's coming from the left side. This gets replaced with a negative. So this will become the limit as x goes to negative infinity as x over negative x, 5 minus 21 over x, bracket 4 minus 3 over x plus 7 over x squared. Okay, so this would be an x taken out 1 minus 3, sorry, that's not right, 1 over x minus 3, and then it's going to be the absolute value of x square root of 4 plus 5 over x squared, all over an x squared 5 plus 4 over x, the whole thing squared. So, remember, because this is an absolute value and it's coming from the left side, this becomes a negative x. Then I have this x and this x canceling with the x squared. This is a 0, this is a 0, this is a 0. What are we left with? 0 minus 3. Minus 3 times minus is a positive. Times of square root of 4 is a 6. And then I have 5 plus 0 is 5. 5 squared is 25. Okay, did anybody try the next one?
Just wait a second.
Did anybody try the next one? I'll tell you the answer. It is 4. Very good. It is 4. 4 for this answer? Okay. Okay, so the highest, you know what, at some point when you get really good at this, you can look at it and tell what it is, right? Because the highest power here is x squared, the highest power here is x squared, and that'll cancel with the x to the power 4, and you just got to look to see what's left. You have a 2 squared times a 1 over a 1, so it's 4. But say you didn't see all that, I'll show you. Okay, so I'm going to factor... It is. I'm going to factor out an x squared out of a 2 minus 3 over x squared. Then I'm going to factor out an x squared, and it's a 1 plus 6 over x plus 5 over x squared. And then here, it's an x to the power 4, and it's a 1 plus 1 over x plus 6 over x to the power 4. So, again, look at what you can cancel. Cancel, 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 right? Those all cancel. The x to the power 4. Okay, so then this is a 0, this is a 0, this is a 0, this is a 0, this is a 0. So do you see you have 2 minus 0 squared, which is a 4, times 1 plus 0, so it's still a 4, over 1 plus 0. So you essentially get 4 times 1 divided by 1. You don't even have to show that, but you get 4. Okay?
Is everything a fraction?
So for a vertical asymptote, as x equals a number, y goes to infinity or negative infinity as x goes to that number. The key here is you get k divided by 0. Well, k, of course, is not 0, because if you get 0 divided by 0, you get a whole. Or if you get 0 divided by some number, what do you get? That's a legit 0. Even though some of you were actually saying that k divided by 0 is 0, it's not the case. K divided by 0 indicates there is a vertical asymptote at the x value that caused the k over 0. The y value is either becoming infinity or negative infinity, and so the limit technically does not exist. And I saw some of you, when you were doing your work, you had something like 5 over 0 times something, and you got a number out of it. You can't have something that doesn't exist times something and get a number out of it. We saw that when we were adding and subtracting functions on graphs. If something doesn't exist in some part of the graph, you can't like multiply it or add it. It's not there, right? So anyways, we try to be more descriptive than just does not exist. We try to add the descriptors. Is it negative infinity or positive infinity? So when we're graphing it, we know if it's going up or if it's going down. To describe the, what do I want? The y values, I guess. And I'll say up or down, right? So let's investigate. So if I put 3 in, and some of you guys are not doing this, remember the first thing when you're doing limits is sub it in. It's only when you get 0 over 0 that you do something more, right? Or if you get the square root of 0, you have to do something more. So let's put 3 in. What do we get? We get 5 divided by 0. So that means it does not exist. We're done. However, at this point now, I want to determine, the question's actually saying, what's the appropriate sign? Meaning, is it going to positive infinity or negative infinity? So in order to do this, we want to know on the left or the right side of 3. So we're going to split this into 2 limits. So the limit as x goes to 3 from the right of x squared minus 4 over 3 minus x. And the limit as x goes to 3 from the left of x squared minus 4 over 3 minus x. So we're trying to determine, is it infinity or negative infinity? Okay, so what does 3 from the right mean? Numbers bigger than 3. So pick a number bigger than 3.
3.1.
You can pick 3.1, or you can just pick 4 or 100. All we care about is the sign here. So if we pick 4, 4 squared minus 4 is a positive on top. Yes? And 4 gives you a negative on the bottom. So what does that mean? It's negative infinity, because a positive divided by a negative gives you a negative infinity. Does everybody see that? Okay. So now this one is 3 from the left. So what does that mean? 2, yes. Or 2.9 or whatever, but 2 is easier to deal with. Mind you, 2 I don't like. Do you see why I don't like 2? Yeah, I'm going to get 0 on top. That's not good. So let's pick something 1.
0.
Can we pick 0? Sure, we can pick 0. That's on the left of 3. So what do we get on top then? We get a negative on top, and what do we get on the bottom? A positive, and what's a negative divided by a positive? A negative. I feel like I'm doing grade 9 math here. So they're both going to negative infinity, so that means it is negative infinity. So what does this look like graphically? Say we have 1, 2, 3. We have a vertical asymptote here, and if it approaches from the left, it's going down, and if it's approaching from the right, it's going down like that. And if I wanted to know, I'm making it look like there's a horizontal asymptote, but can anybody tell me if there's a horizontal asymptote?
No, there's not.
No, there's not. So really, it's probably going like that, or something like that. Okay, so here's an absolute value sign again. So I will now define absolute value of x minus 2 is equal to 2 different things based on 2 different scenarios. It's equal to positive x minus 2 when x minus 2 is greater than or equal to 0. Does everybody see that? And it's equal to negative bracket x minus 2 when x minus 2 is less than 0. Does everybody see how I'm giving this definition? It's the same definition as absolute value, except now it has an x minus 2 instead. So if I move the 2 over, that is x is greater than or equal to 2. Does everybody see? If I move the 2 over, I have x is less than 2. So can you tell me which limit is what? This is the right-hand limit, abbreviated RHL, and this is the left-hand limit when it's less than 2. So the problem here is it comes from both sides, which means what? We can't do it as one question. We have to do it as 2 questions. So it's going to split up as the limit as x goes to 2 from the right and the limit as x goes to 2 from the left. So the right-hand limit, instead of the absolute value of x minus 2, what am I going to write? Just x minus 2. And if you want, you can put it in brackets, but you don't need it. X minus 2 over x minus 2. Does everybody see I'm just transferring that x minus 2 down? Yes? And what does that cancel? And what do we get? What's the limit? It's 1. Okay? The left-hand limit, what are we going to write instead of the absolute value sign now? We're going to write negative bracket x minus 2 over x minus 2. Does everybody see? These will cancel, and what do I get for the limit? Negative 1. So what does that mean? The limit does not exist. Since the left-hand limit doesn't equal the right-hand limit, that's the reason why it doesn't exist. It's not because I got a number divided by 0. It's because I had to split it into 2 limits, and the limits were not the same. Okay? So, let's try this one. Does everybody see? It's coming from the right. Yay! That means I don't have to split it into 2 limits. I know what it has to be. So if I put negative 1 in there, what do I get on top?
0.
I get 0. If I put negative 1 on the bottom, what do I get? 0. I get 0 divided by 0. Does everybody see that? So what does that indicate? You got to do something more. What's the first thing you should try to do when it looks like this? Factor it, yeah. So the limit as x goes to negative 1, what's the top factor to be? X minus 4, x plus 1? Okay, I'm going to leave this in the absolute value sign for right now. Can anybody tell me what this factor is to be? You think it has to be a 5x
5x plus 4
and an x plus 1 plus 4?
Yeah.
Yeah, because you knew something was gonna cancel, right? So that's it. It kind of guides how you factor. If you know something's gonna cancel. Okay, so here's the thing. When I take this absolute value sign out, do I have 2 cases?
No.
No, it's coming from the right-hand side. So it's the right-hand limit here. So what that means is, let's just, instead of trying to do it by definition, let's just try to put stuff that was on the right of negative 1.
1.
What would we get here out of this conglomerate here? Positive or negative is where I'm going with this. I would get what? I would get positive. So if I'm putting in, like, say, I don't know, what's on the right of negative 1?
1. Or 0.
Yeah, sometimes if you go too big, it might be, yeah, you're getting positive out of this, right? Now, does anybody actually remember from, I think it's grade 11,
Yeah.
like what you were supposed to do to actually figure out
Equation of the other side.
if it's positive or negative? It was called a sign, S-I-G-N diagram. And you had 2 things on that sign diagram, right? You have a -1. Oh, and you have a minus, I should actually move it over. You have a -1 and a -5/4. Does everybody see that? Those are the zeros in there. So now, when we took something from the right-hand side, we were okay picking 0. But I caution you, if you pick some, like say we were canceling a 5x plus 4 with a on top, and you picked something like 0, you could be going into a different sign without even knowing it. So I caution taking too much. Just for fun, do you remember how to do the sign diagram? Because this is going to come up a lot in calculus. So pick something on the left of -5/4. -2. So if you put -2 in here and -2 in here, what do you get?
-6.
You get a negative times a negative, which is a positive. What's between -5/4 and -1? Oh my God. Well, this is -1.25 and this is -1. So why don't we just do a decimal? -1.1. -1.1 will get a. Well, what's wrong? Oh shoot! Oh shoot! Shoot! Yes.
It's even worse.
That's even worse. Oh my God! Somebody caught my mistake there. Woo! Yes.
Where are you getting nice negative 4 over 5? Oh, I put it the wrong spot.
Because I'm finding the x-intercepts essentially. Okay. So I moved the 4 over divide by 5. That was my oops there. Okay. So let's pick something between -1 and -0.8. -0.9. I get. What do I get there? Negative or positive? Negative, positive. So I get a negative. And then if I pick 0 in there, I get a positive. So anyways, here's where I caution you, and this is actually why I was doing this. If I'm coming from the right of -1, it's actually negative. It's actually negative.
It goes negative in the last, like, volt.
Yeah, so when you're doing the right-hand limit, if you go way too far, this might come into play here. Well, that's why I'm saying, I know. So what I would say is I would always do a sign diagram for something like that, then, you know what I mean? So, all right, don't worry. So, that just means if I take the absolute value out now, what does that mean? It's going to be what? Negative bracket 5x plus 4, x plus 1. Those will cancel. Yes? So then I put the negative in there, I get -5 on top. Yes? And then what do I get? -5 plus 4 is -1. So I get 1, so I get -5. If I put 5 in there, what do I get?
0. Well, no.
I get -2 over 0. So now what do we do? It's D and E. But on the worksheet, it'll say if it does not exist, you need to tell me the sign, just so you know. So we're going to split this up to be the limit as x goes to 5 from the right and the limit as x goes to 5 from the left. And just to make things easier, I'm going to factor the bottom. And what does it factor to be? X minus 5, the whole thing squared. You know why I did that, right? All I'm trying to see is the sign. And if something is the whole thing squared, do I really even care about it anymore? It's always going to be positive. So if I take something from the right of 5 and I put it in there, what do I get? Negative. And if I go from the left of 5, what do I get? Negative. Don't go too far, right? Because then, like, that's why I'm saying sometimes it's actually better to pick 4.9 just to see the sign. Because if you go too far, then you might be going into the next dimension, yes. So then we'd say negative infinity. Yes? Okay. So this is 2. If I put 2 in there, what do I get? Negative 5 divided by, yeah, 0. So at first glance, I would say does not exist. But what are we supposed to do there? We're trying to see the sign. So we split it up to, oh, this is only coming from the left. So relax. Okay. So we are going to inspect further. So this is x minus 3, x plus 3. And this is x minus what? 2, x plus 1. So I'm just factoring it so that we can see the sign better. So if we're coming from the left of 2, you could say 1, as long as it doesn't make a 0 anywhere. So 1, I'd get negative. 1, negative. So what do I get? Positive. All right. Got to work.